You've been tasked with defusing perhaps the most sensitive bomb in existence. If even a single photon of light hits it, it explodes. But the trouble is, you don't know if it's a dud. It could be perfectly safe, but you'd have no way of testing it without risking an explosion. Or do you? Enter the Elitzur Vaidman quantum bomb tester. You see, there's a curious thing about light. It's quantum mechanical in nature, and we can take advantage of that feature to make the bomb explode in the other many worlds without exploding in ours. First, we have to begin by being very careful with our bomb, keeping it in complete darkness while we set up this experimental apparatus. First, we have a single photon source, perhaps just a dim flashlight, over here in A. And what it does first is it emits a photon and it encounters a beam splitter. Now we're going to place the bomb right here. Now if photons were completely classical particles, what a beam splitter would do is it would send the photon up half the time and right half the time, which means half the time the bomb would explode. But photons aren't classical, they're quantum mechanical in nature, so something slightly more tricky happens. The photon is actually going to enter a state of superposition. Some of it will go up, some of it will go right. And the part that goes right will interact with the bomb and explode it. But the question is, does it explode it in our universe, or in the other universe, in the many worlds interpretation? Half the time it'll be our universe, half the time it'll be the other universe. So we're going to take advantage of the fact that if the bomb is not a dud, then it will have exploded in the other universe and thus won't be able to self-interfere with the photon in our universe. It gets complicated, but follow along. So right off the bat, 50-50 chance of the bomb exploding, we're all screwed, right? Let's assume that we're not in that 50-50 chance. Is there a way to tell if the bomb was a dud or not? Well, actually, yeah. So if the bomb was a dud, we will have set up this interferometer so that the photon just passes right through, and then when they recombine up here, they can only get to the C detector, not to the D detector. This happens because you're going to have self-interference, and so you'll have destructive interference heading towards the D detector, and constructive interference heading towards the C detector. So if the bomb is a dud, you will always pick up a photon at C. But if the bomb's real, half the time it'll explode here and we're screwed. But the other half of the time, it'll explode in the other universe, and so the photon in our universe will have taken this path, and it'll go around, and now it'll interact the beam splitter again, and this time it has a 50-50 chance of going to D and a 50-50 chance of going to C. What that means is that when the bomb is real, we have a 25% chance of detecting the photon at D, a 25% chance of detecting the photon at C, and a 50% chance of exploding the bomb. But the important feature here is that the only time you can detect the photon at D is if the bomb is real, but it didn't detonate. Now you might say that this isn't a great bomb tester because it'll explode half the time, but it turns out you can do some tweaking of this photon circuit and actually find that you will detect if it's a bomb without exploding it as close to 100% of the time as you like.